Most of the students ignore these basic laws of chemical combination, but many times direct questions asked based on chemical laws of combination. Let us see today the important laws of chemical combination. So under first law of chemical combination, law of conservation of mass, it is most familiar law. Most have already studied even in lower classes. Let us see first definition of law of conservation of mass. With respect to reactant or with respect to reaction, if I write total mass of reactant reacted, simpler way if you write total mass of products formed. Total mass of products formed, one method of defining it. Total mass of reactant reacted is equal to total mass of product formed or products formed. So one method of representing law of conservation of mass. In other way, how you can define it? See here, or you can write mass can neither be created. Mass can neither be created nor destroyed. Mass can neither be created nor destroyed, just but changes from one form to another form. Overall, see here, mass can neither be created nor destroyed. The general statement of law of conservation of mass. So who gave this law of conservation of mass? The law of conservation of mass given by Lavoisier. Given by Lavoisier. Basic definition, basic statement, then moving to one question so that you will get more clarity about it. When 4.2 grams of NaHCO3 is added to a solution of CH3COOH weighing 10 grams, it is observed that 2.2 grams of CO2 is released into atmosphere. The residue is found to weigh 12 grams. Show that these observations are in agreement with the law of conservation of mass. So how we need to show these observations in agreement with the law of conservation of mass. So here they specified sodium bicarbonate on reaction with acetic acid, giving salt. We know here reaction sodium acetate plus H2O plus CO2, meaning it is general reaction. Bicarbonate plus acid gives salt plus H2O plus CO2. So here initial mass how much? 4.2 grams of NaHCO3 added to a solution of CH3COOH weighing how much? 10 grams. So here amount you see here NaHCO3, that is 4.2 grams given in the question. Here 10 grams given. Overall how much we are getting? Here we are getting 14.2, that is mass of reactants. Similarly, they mention observe that 2.2 grams of CO2. Here you can see 2.2 grams of CO2 and then residue is found to weigh 12 grams. CO2 gas moved out, that is how much it is, 2.2 grams of CO2 moved out, and the residue, whatever leftover residue, you can say here leftover residue, how much they mention, that is 12 grams they mention. So overall how much we are getting? Here it is 14.2 grams. So here what we can conclude here? So here reactants is equal to products in terms of mass. So you can specify here in terms of mass. So reactants is equal to products in terms of mass. That's what we concluded based on given information. Total mass of reactants is equal to product. Next, moving to law of constant proportion or definite proportions. Law of constant proportion or definite proportion. Here the law statement that is given by Proust. First let us define the statement. Chemical composition of a compound. Chemical composition of a compound remains constant whether it is whether it is obtained from, see statement, whether it is obtained by any method or source, whether it is obtained from any method or source. So what it means, irrespective of source from which compound obtained, the chemical composition of compound always remains same. For example, you see here, I am taking one example. If I take H2O, irrespective of source of water from which it is formed, hydrogen, the hydrogen mass ratio 2 grams here, and then oxygen mass ratio 1 oxygen atom, so here it is 16. So ratio if you see here 1h to 8 by mass, so which is always fixed irrespective of source from which it is obtained. During chemical reaction we prepare water, water vapor is formed. So lake water, river water, chemical reaction based water vapor. Irrespective of the source from which it is derived, water means 2 parts of hydrogen, 1 part of oxygen in terms of number. But in terms of mass, by mass, 1 is to 8 by mass, means 1 gram of hydrogen combining with 8 grams of oxygen by mass. Let us see one question related to it. 1.8 grams of certain metal burnt in oxygen gave 3 grams of its oxides. 1.5 gram of same metal heated in steam gave 2.50 grams of its oxide. Show that these results illustrate the law of constant proportions. So now, based on given data, let us proceed how we need to observe it. 1.8 grams of certain metal burnt in oxygen. So see now, first I am taking here first oxide. Take information of first oxide here. So in the first oxide, weight of metal how much? Weight of metal is equal to 1.80 grams, and then weight of oxygen is equal, total how much it is, 3 grams of its oxide. 3 grams of its oxide is metal oxide. So weight of oxygen is equal to 3 minus 1.8, that is metal amount. If you remove it, oxygen amount is 1.2 grams. So now if I take now ratio of weight of metal to weight of oxygen. If I take ratio of weight of oxygen to weight of metal to oxygen, so here what you will get, 1.8 by 1.2, which is 1.5. So in first oxide, the ratio, that is 1.5 overall, 1.8 by 1.2. I am taking the second oxide. In second oxide, so weight of metal is equal to how much? 1.50 grams. And then weight of oxygen is equal to 2.50 minus 1.50. So then overall we are getting 1 gram. So now weight of metal we got, weight of oxygen also we got. Now if we take ratio, weight of metal to weight of oxygen ratio, which is 1.5 by 1, which is 1.5. So now we observe it. Irrespective of the source from which metal oxide is formed, metal oxide here 1.8 by 1.2, that overall answer is 1.5. Here also 1.5. So what we proved? Two types of metal oxide we observed, irrespective of the source from which it is formed. The ratio of metal to oxygen remains constant, which is 1.5 to 1.5. Hence we proved the given statement. And remember one important statement here. This particular law of definite proportion, it is not applicable, means law not applicable for, it is not applicable for isotopes. Keep in mind, important statement. Next, moving further, law of multiple proportions. See, law of multiple proportion given by Dalton. Dalton proposed law of multiple proportions. So here, see the statement here first. If two elements combine to form more than one compound, to form more than one compound, see here, if two elements combine to form more than one compound, then the different masses of one element, one element which combine with with a fixed mass of other element. With a fixed mass of other element, where a simple whole number ratio, or you can say simple ratio to one another. A simple ratio to one another. Statement you see here first. If two elements combine to form more than one compound, then the different masses of one element which combine with a fixed mass of other element bear simple whole number ratio to one another. So how we need to see? One example you see for explanation point of view. Example C. I am taking simple example. There is carbon dioxide and carbon monoxide. Carbon dioxide, carbon monoxide. So here I am taking ratio of carbon to oxygen ratio. Once observe it. See, if we take ratios carbon to oxygen, how much it is? In first case, carbon dioxide, that is 12 grams, here it is 16 grams. Here also 12 grams, here it is 32 grams. Statement what we mentioned. The ratio of the element which is combining with fixed mass of other element, a simple whole number, simple ratio to each other, one another. For example, C. Here which is fixed? Here the mass is fixed in both the cases. Here it is fixed. Now you take the ratio of other element which is combining with fixed mass of carbon. So here these two, they show simple ratio. That's why it is showing simple ratio. Example number 1. Example number 2 you see here. If I take SO2 and SO3, SO2, here I am taking ratio between sulfur and oxygen 32, 32, 32, here sulfur, oxygen 48. So which is fixed now here? Here fixed is sulfur mass is fixed. Now if I take the ratio of these two, that is 32 to 48, which is, if you simplify it, what do you get? 2:3. So which is simple ratio. That's what they mentioned here. The ratio of masses of the element which is combining with fixed mass of other element. In first example, carbon is fixed. Second example, sulfur is fixed. So now the ratio of masses of the element which is showing change in mass, always simple ratio to each other. In here 1:2, here 2:3. That's what they mentioned in the statement. Okay. And next moving to one question based on carbon forms two oxides. See, carbon forms two oxides. One contain 27.27. Another contain, how much they gave? 42.86% carbon. Show that data illustrates law of multiple proportion. So here you take here mass ratio of mass ratio of carbon to oxygen in first oxide. How much? Percentage, so you can take it as out of 20 and out of 100, 27.27 is grams carbon to 72.73 is which one? Another ratio, that is carbon and another contains 42.86 carbon. Show the data illustrates law of multiple proportion. So in first case, carbon is 27.27%. What about oxygen here? Here it is carbon, here it is oxygen. How we got this information? Because if carbon is 27.27, oxygen is 100 minus 27.27. So after cancelling this, here you will get 3:8. 3:8. Right? And now if I take another compound, means another oxide, mass ratio of carbon to oxygen in second oxide. What are those values? 42.86. How you will get oxygen? Overall 100 minus 42.86 will give oxygen amount, which is 57.14. If we simplify this, here you will get 3:4. You observe it among these two oxides, which is fixed here. Carbon mass is fixed. Carbon mass is fixed. So we no need to see the fixed mass ratio. We need to see oxygen ratio. Oxygen in first oxide to oxygen in second oxide. This ratio we need to see. So there it is 8. You can see now. Here it is 8 to 4. So 8:4 in simpler form. 8:4 you can simplify and write here 2:1, which is simple ratio. Simple ratio for the given information. Here you can see last how I wrote the ratio. After simplification, 2:1 simple ratio. Just a statement we proved by using one simple example. Next, law of reciprocal proportion. Everyone see law of reciprocal proportion. First, read statement. Read statement here so that you will get more clarity about it. When two elements combine separately with a fixed mass of third element, the ratio in which they combine with each other is either the same or simple multiple of the ratio in which they combine with the third element. Once again, read this statement. Important. Read statement once again. When two elements combine separately with a fixed mass of a third element, the ratio in which they combine with each other is either the same or a simple multiple of ratio. So how we need to solve here? Means it is statement. So how we need to proceed further? See now. Let us take with an example, simple example. With the example, you will get more clarity about it. See now. Example number 1. Here I am taking here methane as well as CO2. See the question. When two elements combine separately with a fixed mass of a third element, which is fixed mass here? First you find it. Which is fixed mass? You have to find. Carbon is 12 grams and here 4 grams of hydrogen. 4 grams of hydrogen and 12 grams of, directly mentioned here itself clearly. Carbon is 12 grams, hydrogen is 4 grams. Carbon is 12 grams, oxygen is 32 grams. Which is fixed now? Here see, carbon mass is fixed. Separated with the fixed mass of third element. So Two elements, what are those? Hydrogen, oxygen combining with fixed mass of carbon, that is 12 grams. In both the cases, it is fixed mass. Now, so CH4, CO2. Now you take the ratio of hydrogen to oxygen in two compounds. In two separate compounds. I am taking in two separate compounds. Now, what is the ratio? Here it is 4 grams, here it is 32 grams. If we simplify this, 1 is to 8 by mass. 1 is to 8 by mass, the mass ratio it is. 1 is to 8 by mass when they combine separately with fixed mass of other element, CH4, CO2. If these two elements combine directly, if hydrogen and oxygen combine directly, they form H2O. Now here you take the ratio of hydrogen oxygen in the compound where they combine directly. Hydrogen how much? 2. Oxygen 16. So here 1 is to 8 ratio by mass. So concluding point here, those two elements combined separately with fixed mass of one element carbon, the ratio is 1 is to 8 by mass. If these two combine directly, here also same. So both are same. If they combine directly, they are in 1 is to 8. If they combine with fixed mass of other element, they are also 1 is to 8. So that's what here Richter, the statement proposed by or law proposed by Richter, says that when two elements combine separately with the fixed mass of third element is carbon. I am taking ratio of hydrogen to oxygen here, which is how much? 1 is to 8. If these two combine directly, they form again same 1 is to 8 ratio. For understanding, you take one more example for better understanding. I am taking example 2. Here relation between sulfur, oxygen, hydrogen. Two compounds I am taking here, H2S and then SO2. H2S and SO2. So here what is the mass? 2 grams. Sulfur mass 32 grams. Sulfur it is 32 grams. Oxygen it is, oxygen how much? 32 grams. Oxygen is 32 grams. So now here it is fixed. Sorry. 32 grams, 32 grams. Here it is fixed in both the compounds. So now we need to take the ratio of hydrogen to oxygen in separate compounds. So we need to take hydrogen to oxygen ratio in separate compound. How much we are getting? Here hydrogen is 2 grams, oxygen is 32 grams. So here we are getting 1 is to 16. 1 is to 16. Now, if I 1 is to 16 we are getting here. If those two directly combine, if hydrogen oxygen directly combine, they form H2O. So then hydrogen to oxygen ratio you take here 2 is to 16. 2 is to 16. In 2 is to 16, so what we are getting here? 2 is to 16. If you multiply, here we get 1 is to 8. Ratio is 1 is to 8. Here 1 is to 8 we got, there 1 is to 16. So here simple multiple of it. Whatever we are getting here, that is simple multiple of it. See ratio. Here exactly equal 1 is to 8, 1 is to 8. Sometimes you will get even simple multiple of the given ratio. If hydrogen oxygen directly combine, they form H2 and the respective ratio simple multiple of the ratio in which they combine separately with different compounds, or exactly same ratio you will get. Okay. Next, law of gaseous volumes. Law of gaseous volumes, which is also referred as Gay-Lussac's law. Gay-Lussac's law, it is law of gaseous volume. So it states that gases react with each other. Gases react with each other in simple ratio of their volumes, and if products are also gases, see the statement, if products are also gases, then they are also in simple ratio of volume, provided that all volumes are measured at same temperature and pressure. Same temperature and pressure. This statement, whatever given here. So simple format, what we can see here, if I take N2 gas plus 3H2 gas giving 2NH3, so here you can take 1 volume, 3 volumes, 2 volumes. Simple ratio, what we are getting, 1 is to 3 is to 2. Ratio by volume. See one question given here, see. For the gaseous reaction H2 plus Cl2 giving 2HCl, if 40 ml of H2 completely reacts with chlorine, then find out the required volume of chlorine and volume of product HCl. So what we need to do here? Here H2 plus Cl2, simple question it is. Already many complex questions we already solved. So here they are asking for the gaseous reaction 40 ml of H2 completely reacts with chlorine, then find out the required volume of chlorine and volume of product HCl. So here according to reaction, what we know, 1 mole of H2 react with 1 mole of Cl2 to form 2 moles of HCl. If it is 40 ml of H2 react with 40 ml of Cl2, just comparing volumes. Here moles, or you can take it as ml also, because volume directly proportional to, otherwise you write in volume only, that is because they gave in volume. So if it is 1 ml, 2 ml, 40 ml, then 80 ml here. So overall answer directly here, required is 40 ml, produced is 80 ml. Simple question. Next, Avogadro's law. Avogadro's law states that equal volumes of all gases under similar conditions under similar conditions of equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. Equal number of molecules. So here what we can write, volume directly proportional to number of molecules. And we know number of molecules and number of moles directly proportional. So here you can specify volume directly proportional to number of moles indirectly at same temperature and pressure. So that's what they mentioned in this statement. Statement of Avogadro's law. See, one question given here. Simple question. Volumes given, as we know, volume directly proportional to number of molecules at same temperature and pressure. So as volume increases, number of molecules increases. Highest volume where it is? Nitrogen. Nitrogen having highest number of molecules. Then SO2. Then after that O2. After that N2. Sorry, here in question both are repeated. Here it is not N2. In question here nitrogen as well as oxygen, SO2, H2 you mentioned. So 2 it is nitrogen, here it is hydrogen you mentioned, hydrogen. So hydrogen having maximum number of molecules. Number of molecules. Simple. H2, SO2, O2 and N2 based on number of molecules. Or you can say which is in the respective sequence of volume also. Volume directly proportional to number of molecules. That is about chemical laws of combination. Here in concentration terms topic, we did not discuss about temperature dependent, independent concentration terms. Just I am giving as a note that is concentration terms which are dependent on temperature, independent on temperature. First, molarity, normality, percentage weight by volume, percentage volume by volume, parts per million by volume, parts per million by volume. So these terms, temperature dependent. These terms are temperature dependent. Similarly, other terms like molality, and then mole fraction, mole fraction, ppm by mass, and then W by W percentage, Here you mention clearly which is under which category. And here also specify this one. So overall here in this case, if I observe it properly, these terms you see, these are temperature dependent. Here I mentioned these are temperature dependent, but molality, mole fraction, ppm by mass, percentage W by W, these are temperature independent. Temperature independent. This we did not write in concentration terms, that's why I am writing here. Molarity, normality, W by V, V by V, temperature dependent. Molality, mole fraction, ppm by mass, percentage V, W by temperature independent. How? Because these depends on volume. There is volume term. So remember, if there is volume term in its formula, if there is volume term in its formula, it depends on temperature. So remember, if there is volume term in its formula, then depends on temperature. depends on temperature. Under note you mentioned, important question it is. So with this we completed overall mole concept lecture videos. So after completion of this, the most important mole concept PYQ JEE mains questions we are going to discuss. After that, we are going to discuss PYQ JEE advanced questions in mole concept and stoichiometry. If you do those two, then you will get more confidence. You will get to know which type of questions previously asked. Okay, we will continue with another lecture. Thank you. Thank you for your patient listening.